Hi, it's Jan Beta, and I'm finally going to continue working on the Amiga 3000T that I started restoring last year. Apologies for the delay. Judging by the comments I got on the last episodes of the Amiga 3000T restoration, many of you were looking forward to the next parts. But things went south a bit, in that I took a little break, as I announced in the previous video, and after the break, which was supposed to be 2 weeks or something like that, in the beginning of January, I got a really nasty cold, which basically floored me for another 14 days or so. So it was really nasty, but I'm feeling a lot better and I feel confident that we can do some more work on the Amiga 3000T today. So let's see where we are. In the previous episode about the Amiga, I removed some of the battery corrosion. This was where the battery was, and some of these components here were rather crusted in battery juice. So it took a lot of effort to get all the traces that had corrosion on them freed from the corrosion, and that's basically where we left off. And then I started measuring around to see whether there would be any broken traces, and I actually found a broken reset line to the FPU, which this chip is, and started measuring some more and found that there was only 8 ohms or thereabouts between ground and the 5-volt rail, and I assumed that would be a short. But as many of you have commented, and I got some confirmation from some people who actually own Amiga 3000s and 3000Ts, that is actually quite a normal value for a board like this, where there are a lot of TTL logic chips and other ICs, and especially the RAM chips being all populated. The regular resistance between the 5-volt rail and ground on a board like this is, I don't know, 20 ohms or a bit lower, 12 ohms, 10 ohms, but with all the chips populated in this one, 8 ohms appears to be quite a normal value actually. I got kind of fooled by that because I thought it would be way too low, but apparently it's quite normal. So I apologize for my not knowing about that effect. I hope you understand that I was a bit worried about the low resistance between ground and 5 volts and didn't want to power this on in the state it was in at that time and with the things I knew about boards. Yeah, maybe I was a bit overcautious, but better safe than sorry, I guess, especially with a board that is as rare as this Amiga 3000T. I got many more emails and comments on the Amiga 3000 series videos. Thank you for that. I wasn't able to answer them all, I'm afraid, because I was taking a break at the time. Some of you pointed out that it would be a very good idea to pull the chips that were in the affected area, and that's what I'm going to do today. I always planned on doing that, as I pointed out in the previous video where I did the battery corrosion cleanup, but I kind of wanted to be better safe than sorry again, and ordered some low melt solder, which I didn't have in stock. So hopefully that is going to help with pulling the chips without putting too much stress on the super rare Amiga board. We'll see how it goes. That's the plan for today. Pull the FPU and pull some of the other components around the affected area and clean up underneath properly. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do 3D printing, CNC machining, sheet metal fabrication, injection molding. They can populate your boards for you, and they have a new service that helps you design your boards in the first place. Their pricing is super reasonable, they are friendly people to work with, and delivery is fast. The quality is excellent, so I highly recommend checking out the link in the video description in case you're interested. Back to our Amiga. So yeah, this is the affected area, and there are many small actual components that I don't think I have to remove, but I guess it would be a good idea to at least remove the FPU because that was really caked in battery juice and corrosion. I am going to try to remove these capacitors because I want to recap the whole board as well. So I'm going to put some low melt solder on the pins and then use hot air and try to gently and slowly heat up the pins and remove that. We are going to have to pull these capacitors before, I guess, because I want to have room around this chip. Let's dive in, I guess. I'm not super confident with this because it's such a rare board, but yeah, I'm going to do what I can. I took notes of the values of these capacitors. This is not easy to work on because it's a 4-layer board, as far as I know. Yeah, the problem with the components that are caked in corrosion is that they don't take any solder and also don't take much heat. Hence the idea with the low melt solder. So capacitors removed. Not sure if I want to pull the chip and the socket after this experience. It was really difficult to desolder the through-hole capacitors. Yeah, which probably is because of the corrosion partially, and partially because this is a 4-layer board and there's an internal ground layer. Yeah, as I said, these traces here, most of the traces that were in the battery damaged area are still good. There's one that is cut at this via here and that goes to the reset pin of the FPU. So clearly the FPU doesn't start up like this. And this is where the FPU is, so the trace goes under the chip and from there it goes to the pin. So I'm going to let the alcohol that I just used to clean it evaporate and then tape off the area around the chip to be able to use hot air to remove the FPU. I'm not sure I want to pull the other chips. Probably should, but there's no trace under this logic chip and there's only very few traces under here, I think. Chances are that's going to be fine. The area that was most affected was around the negative of the battery, which is here basically. So this corner of this chip was the most affected. Yeah, let me just get out some Kapton tape to tape off the area. Could remove these little capacitors, but I'm not going to bother, I think. These can be easily replaced in case I cook them accidentally, which I hope to prevent with using some Kapton tape. And this is going to be probably easier to desolder than the through-hole parts because it's just surface mount. And in this case, that makes things a bit easier because it's not going through the 4-layer board. This is a PLCC chip, which has kind of J-shaped legs or pins. I'm going to switch to the microscope view in a second because it's just easier to see. So I'm going to start by putting some flux on here, I think, around the pins, and then we're going to add some low melt solder to all the pins, and hopefully we're going to be able to pull this with hot air afterwards. I'm not quite sure if the low melt solder is going to help with this. Usually you would just use hot air with something like this, like a PLCC chip. The low melt solder is just my foolish idea of making things a bit easier. Yeah, let's see how that works. We're going to start. That takes the solder rather well, I think. Yeah, it's actually good. It's a good sign. Just going to try to get this on all the pins. Yeah, these were the pins that were most compromised here. I think I got some low melt solder on most of the pins now. So hot air next. And then I'm going to slowly heat this up and yeah, try to see if we can get this moving at all. Just slowly heating up the general area here to not stress the board too much. And just going in circles here. Or in a square, rather. There we go. Wow. Okay, that took a while. And of course it looks messy underneath now. Because, yeah, but I don't think I ripped any pads off or anything like that. Which is a good thing. So we're going to do some cleanup work here. And also some cleanup on the chip. I think I'm going to remove the Kapton tape for now. And try to get all the solder off there that I added. Which should technically not be that much of a problem because it's mostly low melt solder. But yeah, this is clean underneath except for that one corner where there is actually corrosion. So good thing we lifted that. Now I'm very carefully cleaning that stuff up. Yeah, it does look reasonable. Yeah, I'm going to have to go in with the glass fiber pen and free some of this area here from the corrosive stuff. But other than that, I don't think we damaged any more than there was already damaged. This pad looks rather compromised, but it is still there. Yeah, but that's as clean as I can get it at this point without the glass fiber pen, I think. So the glass fiber pen is the next step. Basically the same that I did before. Just trying to get all the corrosion off there. And there's another trace that is broken, at least one. That we're going to have to patch up. I think I just pulled that away. It does look reasonably good, but we're going to get a bit further in here. Yeah, it does look rather nice, actually. So we have one compromised trace underneath, and that is the one that's going to our reset pin. I think one of these here. But other than that, it looks really good. And yeah, we definitely have some broken traces here around where the battery sat, actually. I thought that wouldn't be a problem. But apparently, there are some traces that are broken. So we're going to have to figure out where those came from and where they go. And botch them. Yeah, this looks like we got everything off there now. I'm going to try to get the rest of the solder off that one pad there, which seems to be intact, but there's a blob of solder on there. And the via next to it is a bit compromised, but there should still be enough copper left to make a connection at least. Probably it would be a good idea to put a wire through that as well. Yeah, that might just be the cleanup we need to do. It's kind of alright. Could have been much, much worse. Of course, some of these traces around where the battery actually leaked are gone now after some more cleanup. But I think we got all the corrosion off now. Maybe we should do some more cleanup here on this capacitor thing. We couldn't get to that with the capacitor in the way, of course. It does look alright. The traces there don't seem to be damaged in any way. And I actually don't think anything went under these sockets here. And there's a bit of stuff going on here, it seems, but absolutely minor. So I think we're not going to have to pull the chip there. I am going to have to clean my coprocessor chip though. That has some encrustation on the pins now, of course, with the low melt solder. And the pins look rather uncorroded, but we're still going to give them a good cleaning. So yeah, let's do some trace patching and some chip cleanup and things like that. Going to get the microscope out of the way, I think, at this point. Just using my old soldering iron and some solder wick, I think. Just to see if I can get the low melt solder off there. And the corrosion on this doesn't look too bad. Yeah, it does look rather uncorroded, at least despite from surface corrosion on the pins. At least it does look nearly as good as new from the outside now. So yeah, maybe this still works. We're going to find out. Yeah, I did some more cleanup off camera, and indeed it looks pretty nice under the chip there, or under where the chip was. So trace damage. We have one here, I think, is the one that is the reset pin on the FPU. And that is badly corroded on the backside of the board. On this side, it isn't corroded that much, but on the backside. So what I'm going to do, probably, is to run a small wire through there. Yeah, this is the one on the backside here. I'm going to run a wire from a resistor through that, I think, which I also use to clean these vias. So I'm just going to stick this through there, I think, and then solder it to the remaining trace here. Just bend it over like that, and on the top side as well. And then that should be the connection to our reset line. So, blob of solder. And on this side, we're just going to bend it. So this pin should now connect to here. Yay! Okay, that's the first connection that I made using a resistor leg that fits these vias. And I'm going to do the same for some of the vias that were a bit more compromised. Just going to stick some wire through there so we have a better connection. So that's the other via that was completely gone. I'm going to show you what I'm doing here in a second. So basically what I did was patch up the vias. There is one via here that's a ground connection clearly connected to the ground plane here. I just ran a wire through there, ran a wire through this reset pin here, ran a wire through this, which I think is VCC. That's 8 ohms against ground. And yeah, I just used a lag from a resistor that just fits the vias to make sure that these don't corrode any further. I think these were connected, this wasn't. But just to make sure that if the corrosion goes on, we don't have to pull this chip again. Because that was a bit of effort. Yeah, think that's about this here, this area. I'm going to keep looking for more compromised vias, I think, but this is the next area where the battery ate away some of those traces that run under the battery. Surprise! Which is it's not really great design to run those under the battery, I guess, but it's only 3 traces that were completely eaten away, or rather that rubbed off. I think they were all intact when I initially started the cleanup process, but yeah, better to remove a bit of the trace, which is corroded, than to leave it on there and let it be eaten further. And that's 3 traces. I think I'm going to patch these up with magnet wire from the backside of the board. That's probably the reasonable thing to do. These are really, really small traces, and it's not going to be easy to patch them on the front side here. I don't have any wire that is thin enough for that. But they are going to the FPU here, and there's vias for all the connections, I think, and most of them should go to vias here somewhere, so probably we can just patch them with some botch wires on the backside of the board. So we have these traces in this area here that are clearly broken, and they all go to this side of our FPU, so it is relatively easy to determine which broken connection goes where on here. There's convenient vias here, and the other end of the connections are going off somewhere here and then into the rest of the board, basically. So we need to figure out where this end of the broken connection goes, which is easy because we can just measure with the multimeter, and I already did that. And then we are going to have to figure out what these are supposed to connect to and find some place where we can put a botched wire. I think on this end it's pretty clear that I'm just going to use these convenient vias here and stick a small wires through there and solder it into the via. And on the other end we are just going to find the next via that connects to where the other end of the broken connection is supposed to connect to. And for that, I looked at the schematics and tried to find a chip that we can easily measure the connections on. These are data lines, it turns out. That's these here. Pin 68 is data line 3, pin 67 data line 4, and pin 66 data line 5. These are the broken connections, which I determined by counting the pins and measuring connectivity between the pins on the FPU with the cleaned up traces there that are bare copper at this point. And then I looked into the schematics, which I'm going to link in the video description again, and looked for a chip where all these data lines go. Of course, the data lines go through the whole system, but I found U255, which seemed pretty convenient. These are the pins on that chip that these data lines are going on the other end. So this end goes to the FPU and the other end goes to the whole board, but also to U255. So that's a convenient way of measuring where these are supposed to go and finding vias in this area here probably that we can connect our botch wires to. It's going to take some time, but very much worth it, I guess. So probably not easy to film the process, but I think you get the gist of it. I'm just going to measure around and make some markings, I think, with a waterproof pen. Oh, okay, this end goes there. Okay, so this is probably not a good way of figuring out where that goes. Okay, so we need to find another chip where these are supposed to connect to, I guess. On this end of the thing, because the traces here go to this chip from this end, so it's not a good indication. Yep, we have a connection again. Okay, so we have pin 66 reconnected. And I'm going to double check with the schematics after this, I think. As I said, I'm just looking for the closest via. Okay, that's good. So we need pin 68, which is this one. That is this trace and this trace. And that goes to this one here. Excellent. So we made a connection here. We made a connection here. It's not connected to any of the other ones. And we made a connection here. Yep, that's the correct one. Okay, so we patched up our connections. That's good. Let's see if we can determine where these are supposed to go on some chip that is a bit further away here. I'm just going to clean this up a bit. So yeah, it does look a bit messy, of course, because these are botch wires, but I think we're going to be fine with that. And of course, I'm going to have to seal the area where there's exposed copper with some new solder mask. But I want to determine all our connections are there first, of course. And this is a much better chip to check that connection on U180 and U181 are our kickstart ROMs, and our data lines go through there, the ones in question, D3, D4 and D5. There's 32 data lines actually, D0 to D31, because this is a true 32-bit bus Amiga. Yay! That's pin 19. And we have D4 on pin 22. Yep. And pin 24 should be D5. Yep. I think all other connections are there now. So far, so good. And we don't have any shorts between any of them, which is also always a risk if you're running botch wires. These don't short out with each other at least. And it should be relatively easy to solder the 6882 back in there once we have sealed up the circuit board on both sides. Yeah, I guess that's the next step. Going to seal up everything we don't need to solder to anymore. Now for sealing the circuit board or the bare copper traces that we cleaned off all the corrosion I could find, I'm going to use UV curable solder mask. Has worked fine for me in the past, so I hope this is going to be no exception. And it continues to work fine. We're going to see. I'm just going to probably use a Q-tip to apply it. And yeah, I'll start here. And the good thing about this stuff is that it doesn't cure until it's exposed to UV. So can take our time. And I'm just going to put it everywhere that it needs to go. So everything is green that doesn't need to be soldered on anymore. Okay, I think I did a reasonable job. Of course, these pads here need to remain solder mask free. And we're going to have to do the flip side of the board, the bottom side as well. Yeah, I'm going to shine some UV light on this, I guess. Yeah, this came with a UV flashlight, which is not very powerful. But it does the job. So what I usually do is to prop this up and let it shine on there for a bit. That UV flashlight is not very powerful, so it took a few minutes, but now we are cured. Mostly. Some green rub off there, but should be good enough. So let's do the other side. Just the same thing on the bottom of the board. Just putting my flashlight directly on it now. I think that's probably the fastest way of curing this. I'll report back. Okay. Yeah, it's not completely cured, but yeah, that's just the top layer there. Should be good enough. And it doesn't look half bad. There's all 3 botch wires. Should be ready to put a 6882 chip back in there, I guess. And I'm probably going to have to reuse the old chip for now. I don't have any others. I thought I might have one, but I don't have one. And I have no way of testing this one, but I would guess it's still fine. It wasn't really corroded that badly on the pins. After cleaning up, it looks relatively clean and basically as good as new. So yeah, probably that's the next step. Solder this thing back in. And I'm going to use the microscope for that again, I think, just to align it properly and to make sure it sits on all the correct pins in the correct way. Of course, it doesn't look very nice under the microscope, but I think we can put this back in. And I think what I'm going to do is to put a bit of flux on all of these pads while we have this exposed still. And also put the chip in there with there's a little dot on here, that's pin 1. So we want this in here, something like this. Okay, I think I have it positioned on all 4 sides here. It's really difficult to do, especially since the board is really huge. These pins here are all connected together anyway, so it doesn't matter. Yeah, that's going to be some great footage. I'm sorry, it's really difficult to do this with the microscope in the way there. Yeah, it does look really promising. I think it should probably be all connected now already. But we're going to measure every single pin. After the fact, and also see if we have any shorts or anything like that. So yeah, I'm going to have to clean this up thoroughly and then have another look and actually measure continuity and things like that. But it appears to look rather promising at this point. Yeah, sorry I wasn't able to film that properly, but my chip is back in, more or less. We are going to have to check each pin for the correct connection. So that's what I'm going to do now. I made a list, 68 pins to go through, and I have the schematics pulled up on my computer here. And I'm just going to check all the pins for continuity to the correct spot. Some of which are really easy because there's a via right next to it that I'm just going to check continuity to. And then I'm going to tick them off my list and see if they are all correctly soldered down and making connection to where they are supposed to make connection. I already did a lot of rework on this chip and it doesn't look really nice, but it should connect to all the points now, hopefully. Let's see. So yeah, I'm not going to talk much about this, just going to do it. And then we're going to go on. I think we're good. So next step, putting the capacitors back in that we removed. And I'm of course going to use new capacitors. Relatively easy task compared to what we did before. But still, going to take good care to not destroy anything here. Okay, cleaning up. We're getting closer to the moment of truth, I guess. Okay, got my 3 capacitors back in. Cleaned this up a bit. Still a bit wet from the alcohol. Yeah, this doesn't look great, but it's on there and it seems to be connected in the right spots. We're going to find out shortly. Next step is going to hook up the power supply to this after checking the power supply for the voltages. I got the case, which still has the power supply in it, out again. And this is the connector that transports the power to the mainboard, ideally. Hook this up to an outlet and we're going to see if it does anything at all. Haven't tried this, haven't turned this on at all. Hitting the power button here. Okay, the fan in the power supply spins up. I guess that's a good sign. Let's see if the voltages are correct. Now we have this connector here that is color-coded in Commodore's weird way. I guess they wanted to make this standard. The blue wires are ground, I think. The yellow ones are 5 volts plus, or supposedly. The orange ones, I think, are 12 volts. And then we have minus 12 on one of the other ones and a tick signal. And I think minus 5. So let's see if we have all the voltages we need. Set the multimeter up to volts DC, obviously. So yeah, let's pour this on and see what we got. So one of the ground pins here. And this should be 5 volts if I'm not mistaken. That's 5.3. 5.3. 5.3. Yeah, and this should be 12. That's 10. But that might be regulated down. It's this one. That's probably our tick signal. That looks like a tick signal. That's fluctuating. That's our brown wire. I'm not sure about the pinout. The most important stuff is the 5 volts at this point. And that's probably our minus 12. That's minus 8 at the moment. And that's our minus 5. So we have the voltages that we need. Some of them don't appear to be spot on. But the 5 volts at least seems to be good. So possibly this is modern enough that it only works correctly under load. It's a switching power supply. The fan is surprisingly quiet for a machine of that era, actually. Yeah, there's another fan down here, but that didn't turn on, of course, because that's connected through the mainboard. I think we can, at least we don't have any overvoltage or anything hilarious like that. I think we can dare to use this original power supply to try to power on our board. Let's see how we manage that. I don't really want to take it out of the case, but I might have to. Yeah. So this is the setup currently. I put this on its head and it should be enough to connect the power connector. So this should be ROM 0. And this should be ROM 1. I'm just putting everything back in. Yeah, just double checking. ROM 0, ROM 1. Okay. And then this connector only goes in one way. I also connected the monitor already to possibly see something on it. Let's see if this reaches over here. Yeah, it just works. Okay, first trial. It might take ages to boot up because we don't have anything in terms of SCSI connected because, yeah, not sure how to terminate the SCSI, and I also don't have the little connector for the lock here connected. I'm not sure if this is going to boot up at all like this, but I'm kind of willing to try that out. Let's see. Let's see what it does. Okay, fingers crossed so much. This was a lot of work and there might still be a lot of things wrong here. Let's power this on and see if it explodes. Oh, got a white screen. That's a very, very good sign. That means things are better than they were. I think this displayed a yellow screen initially. Yes! It works! It just booted up to the kickstart screen and it didn't even take long without anything connected here. Oh god, I'm so relieved. Okay, that basically means that most things are alright. That is really, really good. Yes! It just worked first try. That's awesome. I mean, we don't have anything hooked up in terms of expansion cards or anything like that, but it displays a clear, crisp picture. We have our Kickstart 2.0 ROMs that are working. We have this machine initializing. So yeah, it seems this just works at this point. I haven't tested it in detail, of course, but this is very, very promising. I'm happier than I ever was, probably, with a machine that's just displaying a Kickstart screen at this point. Yeah, rare Amiga 3000T back in business. So far. There's of course lots more things to do on this and lots more things to check, but I think this video has been long enough. I'm going to continue working on this and I'm going to release more episodes when the time comes. I'm so very, very relieved. Yes. It freaking works. Yeah, that's it for today. We have a basically working Amiga 3000T board. Lots more to do on the case, on the expansion cards, on the board itself, but that's going to be covered in future episodes. Hope you enjoyed this one. Thank you very much for your time. Special thanks, as usual, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page or elsewhere. The links are on my website and in the video description in case you want to give me some support, which of course is highly appreciated. That's it for today. I'm going to have to take a nap now. Thanks for watching. I'm Jan Peter. See you next time. Bye.